Hello and welcome to this video from In3D Software. Today we're going to have a step-by-step tutorial on how to make a reception desk. Right now we will just open up a example file that was provided to us by our customer or an architect. We have a technical drawing of a plan view of a reception desk, and I'll just delete out some of this line work here that is not going to be needed. The first step will be to measure the size of the pedestal that the architect's asking for. So we can see here that it's 430 millimeters wide by 550 millimeters deep. So the tool we will use is Article Designer. So if we click top view, we can then create a product using the Article Designer tool. I'll set some presets here for office furniture and insert some parts into the tree. I can then make some alterations to these parts, perhaps change the type and the method of connection, and then change the overall sizes. So I know that the height of the pedestal needs to be 720 and the width, as we saw, was 430 and the depth 550 millimeters. I can then switch to a 3D view within Article Designer and use a simple linear division to create 3 drawers. I can then specify what type of drawers these should be, and I have some preset drawer constructions from the data already made, so I can just quickly assign these, and I'll modify my linear division here ever so slightly. I need a base on this, so what I'll do is click at the highest level of the tree and switch to a base construction, and I can change the overall method of that construction here so that it is only 80 millimeters high. I'll save over an old drawer pedestal file, and then I can insert this into my order, and I'll roughly place it here just over the reception desk technical drawing. So I can check this product that I've just made by switching into a realistic view and increasing my level of detail. Imos will refresh the model and we can see a higher level of finish to the edging and the hardware. This looks good now, so I think it's time we move on to the next stage, which is to create the main body of the reception desk. I'll go back into a wireframe view and a plan view and make a quick measurement here of my line work that the architect's provided again, so I know that it is 600 by 1800. And if I then switch into Article Designer again, I can use those dimensions. So I know that the height needs to be 720 millimeters to the underside, which is the height of my pedestal, and then the width and the depth. And again, I'll set some presets here that will use defaults for office furniture standards. I can then assign a top shelf, which I need to change to be edged all the way around. And I will then add in a left side by double clicking right side, and also a rear will need to be added in as well, which will form the modesty panel. First though, I want to change my left side so that it is only edged on the leading and bottom edge, which is edge 1 and edge 4. So we can alter these codes. That's because when I put my modesty panel in here, my back panel, I want to use a mitre to connect my left side and right side so that I get a hidden line detail. I'll save a new version of this back and remove the connectors in here because I want it to be a mitered joint rather than one that's using a dowel or a knockdown fitting. I can then switch to the trims and change it so that it is mitering to the previous side and the next side, and if I switch to a top view here we can see that the side panels need to be told to miter to the previous, and in the case of the right hand side, the next side. So now that we have a miter running all the way around, I'll save over my old reception desk, and I'll also save a copy of this with a slightly different width because there's two parts to this overall design. So this is going to be the shorter length, that's 800 wide, which I can then drop in. I can place this and then rotate, and then move this over to one side, and I'll use AutoCAD snap commands to drop this accurately in place. I'll drop down in our visualization level here as well, just to make it a little clearer on the screen. And if I refresh my article list, you can see the reception desk that I've made previously is in here as well, ready to be inserted and then repositioned accordingly. I think we need to have a little look at this again. They all seem to be inserted at the correct height. I want them all on ground level at 0 on the Z. If I orbit around in 3D, I can see that I have the ability to then reposition this if need be. So the next section to look at is this top part with this funny looking cutout to the top surface. I'll use AutoCAD dimensioning again to get my overall sizes. So this is 370mm by 1800. And if I use Article Designer, I can again specify those dimensions. So I'll put in here a rough dimension of 1500 high with my known dimensions. Okay, and now we can add some parts. So I've got my top on my left and my right. I'll make some alterations to the top. I think I want this to be edged all the way around again. So I need to find one from the list. This one will do. And then I have my side panels. These look okay. I'll use a divider to split this product and use a linear division. So if I type in 738mm to 1, this will divide my product in height and give me two zones. So in the upper article design group, I can then specify a back, which is going to form part of my modesty panel. I can then change the back, and what we need to do is push this into the product. So I'll use an insert here with a value of 150mm. This looks okay. So I'll click tick and save the product, and then I'll just save this as hutch and click tick. Let's just drag this over and put it into position again using the AutoCAD snaps. So it's clear that my side panels are not the right thickness, and I need to move this modesty panel. Let me measure here. 25mm. So let's move this back by altering the inset. This looks better. 125. Okay. I have my width wrong, so let's just modify this. Okay, let's change the width. I'll save over the original data. This is better. It's far too high though, I think. This needs to be reduced in height. So let's modify the article again. Change that height to be 1200 and overwrite. Okay, this is better. I'll use an article related variable. Select the product, and now we can find the variables relating to the actual materials used. So in here I've got a material for the carcass, and I can come into the data and I'll find the oak material. Where is it? Here we go. So the thick material I have is, let me find oak. Okay, is only 38. Let's save a copy of this at 50 millimeters. It's better. I'll overwrite my database information here as well. This will be important because it will be showing up on my cutting list later on. So let's change the thickness of this particle board to be 50 millimeters. I'll also specify a color matched edging tape. So I want a wood grained, let's see, this is unicolor, here we have wood grain, and an ABS oak tape. That's better, but I only have it for a thickness of board up to 43 millimeters, so I need to change that. Let's make this 50. And I will change my raw height, which is my finished height, to be 50 millimeters thick. This is better. I'll save this now and apply these variables. And let's switch, I think, now into a wireframe realistic view. This is better, but I want my upper modesty panel now to be in oak as well, I think. So let's switch this over using, again, the article related variable. So I go to the back and I will now just specify this to be a 19mm particle board in oak. That's better. Yes, this looks a lot better now. So my side panel is clashing with my desk, but that's not a problem. I just need to make a cut, which I can do later on as well. So the next step is to create a secondary hutch. So I can do that by refreshing my article list and finding the original one. And I can then modify it from the list and save a copy after I have altered the width. Let's change that down to 800 wide. I think we should probably save this as hutch 2. We'll put this into position. I'm going to need to rotate this. I also think we need to modify the position as well. Let's bring this down and make it a bit narrower. This should then line up with our, yes, that's better, line work. I just need to select this and rotate it. There we go. I'll just copy my settings here. And then use article related variables. This is better now. article related variables. So now this is using the right materials, I can put this into position again. And this is looking good. I think we should have a look at this from the side. I need to notch the side panel here to take the main body of the reception, so I can use a polyline like so. Just need to snap that, and then I can select the edge here, the line that I've created, and then tell it to conform to the polyline. So if I select the edge, I'll just find my modification, and under joint functions I can then select the polyline and click tick, and that now makes my side panel have this notch design. I can then use the same polyline and I'll just copy and rotate this. Let me just rotate. Okay, this looks better. Nope, yes, that's the wrong way around, so I need to rotate that again. There we go. I'll just move this back into the correct position. And if I just select the edges, I can do the same modification. Okay, this looks good. Let's switch into a realistic view. Yes, I'm happy with this, I think. Next stage then is to create the curved section, which is going to bridge the two straight sections. So I'm going to use AutoCAD polyline to trace the geometry that was provided by the architect. And I just want to change this into an arc and then close this geometry up. I can then snap it in position, and what I'll do is just pull this geometry up, I think, to be the height of the actual worktop. So I'll just move this 720. Okay. Next stage is to use a tool within Part Designer. Okay, no, this is the wrong tool. There we go. To create a contour part. And I need to change the vertical offset so that it is set to 0. And I'll use a part type of work surface. And I want a part definition that says that it's edged all the way around. This looks good. I'll just isolate the geometry here so that I can start to create the other pieces. So I'll use a part edge and alter the default settings. So I'll change the part definition and the inset here so that my side panel is just inset the correct amount. I think I also need to bring these edges in here, front and back, just so that they're not completely flush. I'll do that here with my offsets to the left and to the right. So I can say -2 on the right and -2 on the left, and click tick. This looks okay. I'll repeat the process on the other side, and it's remembered my default settings. I'll just change this part definition here to be a right hand side panel. And I can confirm this with a tick. The next step is to put in these curved sections here. I'm going to have to create some quick measurements. I'll use the same tool, part to edge, select my edge. This is pretty easy to just take some measurements and tweak this now. So I have my first curved piece of 12mm flexi-ply inserted. I'm going to need the second piece as well, so I can have a front and back section as per the drawing. I'll use part to edge again, and again select that rear edge. It'll remember my settings, and then I just need to offset that, the additional 112mm. Yeah, I need to push that out a bit further. That's better. Great. So I'm going to need some sort of vertical support for these pieces running up and down. So again, I'll use the contour part tool, and I need to use the polyline from AutoCAD to draw my internal rib or support or whatever you may call it. So select this geometry and I'll just snap it to the inside piece. Yep. And then I'll move it up so it's not completely on the floor. Let's give it a height of 100mm, and I'll use the copy selection command with one of my favorite AutoCAD tools, which is array, so I can space this out. I'll use the snapping point here so that I can array it, and then use the fill or fit command so that I can space it equally in the height, and use the snap points to get the correct spacings. So this looks okay. I'll use the contour part tool and just select all of those, and I just need to move this down. I'll give it a negative offset, the thickness of the material, so they all move down a little bit. So now I've got my structure. So when it comes to assembling this piece, the production team can put some pins or brads, nails, screws through the 12mm flexi-ply into these curved sections to help keep its form, and then over laminate this by hand. There's lots of different ways of creating these parts. I'll make sure that these have a laminate surface applied to them so that you won't see the screws. Okay, so here we have the bottom surface. We'll just apply a high pressure laminate in white to this piece and to the top surface as well, although this might be some sort of balanced laminate, I guess. Let's have a look in realistic view. Yes, this looks good. Now I'm going to need some grooves, I think, in this to make sure that those pieces are connected into the sides, keep a tight fit. Let's go back into a wireframe view, and we'll come back to that, I think, let's carry on using contour part in the part designer. We'll make some decorative worktop, I think this is, or some sort of addition to the existing worktop to make it look like the thicker material is running all the way around. So I'll use the same tool as before, the polyline tool, and I can switch between line and arc segments within the polyline by using L and A and pressing enter in between, and then C to close it. And I'll just move this up so that it's in exactly the correct position. This looks good. And I need to use the contour part piece here. And again, it's remembered my previous settings, so I need to make some alterations here. So the next step is to alter the grain direction on this particular part. We would like it to run across the overall width of the part and not in one angle that's at 90 degrees to the straight edges. So if I draw a line that bisects the overall part, I can then select that line and it will run the grain along that line. This way the grain will look like it's continuing a little bit better around the overall reception desk. So what I'll do is just hide some of the original construction geometry and some of the supplementary geometry that I've created, just so that we have a cleaner model. And we can orbit around here a little bit and just inspect the overall design, make sure we're happy with everything, and then we'll move on to the next stage. So after a little checking and making sure that everything's okay, we'll move on to the next part, which is the reception desk hutch. Has this funny shaped cut or notch in it, and we need to apply this to our part. So what I'll do is trace over the original geometry from the architect, again using the polyline command from AutoCAD, but this time I'll just select the leading edge of this part. What I can do now is use the geometry that I've created and tell the part to conform to that shape. So I'll just move this up a little bit, and then what I need to do is select the front edge of the reception hutch section, and then use the command extend to polyline. That will then shape that leading edge, which is exactly what we want. And the architect has also asked for some cable management, or access holes, or whatever you want to call them. And this is quite easy to do. We can again use AutoCAD circles or polylines and then transfer this as machining to the individual pieces. So unlike traditional 3D modeling, where we could use a cylinder shape that's extruded and then used to subtract away a piece of material, what we do here is use imos commands such as circle to pocket, which I'll use in this case on the top piece, and that will then identify these features as machining elements,
which then need to be passed to the CNC machine later on in the process. And because imos can detect the different parts and material and machining features, it will know which machining elements to use certain tools on. It will know that certain thicknesses of machined parts need to have certain tools or feed, speeds, lead in, lead out. All of these elements are based on conditional logic, so it will then automatically create all of the machining data with all of the tooling information automatically assigned. So here you can see, after I've turned the level of information all the way up to the highest level, the pockets have been passed into all of the parts and are now ready for the next step, which will be documentation. We'll just have a little look around here and make sure everything's okay, we're not missing anything. This is looking pretty good. I probably should add in some machining for these side pieces as well. So what I'll do is select the part and then say that it should have a groove. Here you can see in green a groove macro has been added to the part, and I can use AutoCAD Snap to position this exactly over the piece of 12mm flexi-ply that's pushed into the side panel. And then I can alter the groove and change the position of it, the direction, whether it's a saw groove or a milled groove. And then importantly, I need to change the width and the depth to make sure that this is just in the right position. Maybe a little bit wider because we need to allow for the laminate as well. This is a bit better, I think. And then I can just copy this and position it again. I need to delete out the other groove as well down here, which I put in by mistake. So I'll just go to the Modify tab and delete. I'll repeat this process for the other side. And then we're nearly ready, I think, to start documenting this. So with the grooves on this final panel almost complete, the next step will be create some technical drawings or submittal drawings for the architect to sign off on. I'll use the imos drawing views tab to create some plan, elevation, section drawings, detail drawings, that sort of thing, and we'll create these now. I'll speed through this section just so that we can save a bit of time, and I'll come back after this has been finished.
So with the drawings now complete and saved to a PDF, these are the final results. imos also has the ability to automatically create technical drawings as well as a number of other types of reports. For example, here's a quotation that was produced calculating the overall costs based on material usage, labour times, etc. With Document Manager, imos is able to create individual product drawings. Here's an example of the hutch that was produced using Document Manager. So we have an overall drawing view, and these can be used to create part drawings as well if need be. So now that the outputs have been saved, the next step is to put this reception desk into production. We can save the order and ask imos to generate the CNC data. And what will happen now is the automatic program generator will be presented and we can run a workflow. Down on the bottom bar you'll see the PXM progress bar. These are the native CNC files that are generated via imos, and then we use a post-processor to translate this into CIX files for a Biesse workflow in this case. With this complete, we can then have a look at the results via a report, and we can investigate further the machining processes that are applied via the report. We can also then look at the CNC results within the native what program. So here is B Suite, a Biesse piece of software which has a number of different machines assigned. And if I open up this part here, which is a piece of 18mm white melamine board, here's the corner section of the reception desk. So we'll wait for this to load. Okay, and I'll just rotate this view around and zoom in a little bit. Here you can see all of the machine has been automatically assigned based on the principles within imos. So I can simulate this program now and just show that it is machine ready. I'll slow it down a little bit and remove the waste. So Biesse will now calculate all of the machining. I might have slowed this down a little bit too much, but you get the idea. So the first cut is now complete. It will come around and do a format contour to size the part. And then finish off this cut. Then it'll do a cleaning pass to get a very fine finish, because this part has curved edge banding that's applied on the actual CNC. So this is using a 5-axis machine with an edge banding aggregate, and because in the part in imos we told it that it should be edged on the CNC machine, it knows to then blow off the dust and then come in and apply the edge banding strips piece by piece. So we've done edge 1 and edge 2 here. We need to trim these off, so the trimming saw will come in, trim these flush, and then we can apply the remaining tape. Okay, trim them again, and then we will trim the tape flush with the surface. This looks good. All of these settings have been calibrated within Biesse, of course. So you would set up the machining principles within imos and have these triggered based on certain conditions. The fact that the edge is told to be on the CNC rather than before the machining process or after the machining process is critical. But once the edge has been identified as being edged on the machine and trimmed in a certain process step, you are then able to send this to the CNC, and in this case it's going to run through all of these steps based on some rules that have already been configured within the B Suite software. So that's one piece generated. Let's have a look at another one now. Another unusual shape. If you remember, we made the hutch part. So let's have a look at this one as well. That had the pockets for cable access in there, so that those pockets will come through with tooling already assigned. Here we can see. And again, because this is an unusual shape, we want to edge band this on the CNC. So we'll wait for this to load up. Okay, and let's rotate it around a little bit. So again, there's a bit more involved in this process. The material is slightly thicker. We may need to have additional format contours to machine through this in 2 steps rather than 1. Again, that would be a setting that is set within imos and would happen automatically because it knows the thickness of the part. So it would automatically create a 2-step pass. So here's our first step. This is a little quicker now. I've not moved the speed down so much. And there's our second formatting pass. Put a little less stress on the cutter. Okay, and we have some drills, and then we have our pocketing. So again, we have rules that will determine how many steps the pocket needs to be completed in, and the speed, direction, lead in, lead out, all configured directly from imos, so that all of these settings are done automatically, and the programs can just be run within the B Suite software. There's our clean pass, our edgings being applied and trimmed, and the back edge, clean this up. Let's run around with a scrape. Just a little bit quicker here. Okay, this looks good. Let's open up one more program. In this case, we'll open up the side panel for the hutch, which has the notch taken out of it so that it can sit on the reception desk. They're a very simple program. This time there's no edge banding required. We just need to machine the outside contour of this. And again, because of the thickness of the part, it's going to do this in 2 steps automatically. We also have some edge drilling here as well. So this brings us to the end of the tutorial for the reception desk. Please feel free to contact us if you have any questions. Thanks for watching.